Nobody's allowed to say anything. Okay, can't have your voice on a recording. If you want to say something or ask something, just raise your hand. If I don't see you, throw something really hard at my head. Okay? And that might get my attention, and I'm pretty hard at it. Okay. Seriously. I prefer pandemonium, so when I turn this off, I invite pandemonium, okay? Yeah, just bust in any time, get a conversation going. It's really a good thing. Unfortunately, privacy concerns mean that if your voice is on the recording, I'm really not supposed to use it. Okay. Okay, so anyhow, okay, A, B, and C. Okay, just a couple things about this. Okay, in my case, I just picked one out and I got the most boring possible set of numbers, 5, 7, 9. Okay. It says something about me, I don't know. Okay. Now, I'm going to ask you real quick, just got a piece of paper in front of you. I can put these numbers on the number line. 5 goes here, 7 goes here, 9 goes here, right? Do that for your numbers. Put them as they need to be on a number line. And now 5, 7, 9 are equally spaced in the number line, aren't they? 7's right halfway between 5 and 9. Okay. If I have the numbers 4, 6, 12, well, 4 is not all that close to being halfway between 6 and 12, right? What's halfway between 6 and 12? Show me with your fingers. Between 6 and 12 would be 8, right? No, actually be 9. Okay. No. Yeah. Halfway between 4 and 12. Okay. What's halfway between 4 and 12? Okay. 8, right? From 4 to 8 is 4 units. 8 to 12 is 4 units. You can add 4 and 12, get 16, divide by 2, that'll give you the number halfway, right? So if your number here is not in the middle, then this number is going to be closer to one of these than the other. Turns out that 6 is about 3 times closer to 4 than it is to 12. Exactly 3 times. It's only 2 units from 4. It's 6 units from 12. That's 3 times as far. So this distance ought to be 3 times as far as this distance. And I didn't quite get it right. 3 times this distance would be here, here, here. It'd actually be out about here. So if I wanted to correct this, I'd actually put 12 maybe out here. Okay. That's kind of important to get the general approximate relationship right. So if you got 3 numbers in the middle is closer to one of these than the other, your picture should indicate it. And preferably about how much closer. Okay. That's just a skill you're going to need shortly. You want to start thinking about that. And it's easy. You won't have any trouble with it. Okay. So now which of these are true? Well, you can plug in your numbers and see. Is A less than B? Is 5 less than 7? Yeah. Okay. Is B bigger than C? Is 7 bigger than 9? No. Okay. So this is true. This is false. But it says and, they're both going to be true. It said or, then it would be a true statement, right? This is true. This isn't, but it says or. Okay, well, not going to get too deep into logic. It's kind of necessary to understand something about it. And A plus B less than A plus C. You don't really need to plug in your numbers, but that's fine. Most of you did. Okay. If you add A and B, in my case, you get 12, whatever you get. And then you add A and C, I get 14. 14 is less than 12, so that's true. And it's going to be true for anybody's numbers because A, B, and C are in order from least to greatest. If you don't have them in that order, then you want to put them in that order and kind of redo this. Okay, redo, your D, E, and F, and G. Okay. Another way to say it is, well, I know that B is bigger than, that C is bigger than B. So if I add B to A, it's got to be less than what I get if I add C to A. I'm adding a bigger number to the same number. And that's going to make this one less than this one. That's a general principle of mathematics. It's a little more abstract than just doing it for numbers. So you want to be able to see this as abstract rules that apply. You can always check it with numbers. But know that general principle, well, that goes a long way towards solving linear equations. Okay, means I could subtract A from both sides and I'd still have a true statement, right? Well, it does. And I'm saying that kind of fast, we work that out. Okay, A plus C greater than A plus B plus C. Well, I mean, you got A and C here, you got it here. So A plus C is going to be the same here as it is here. B is a positive number, all these numbers are positive, so this has to be bigger than this. So that's A, so because it says this is bigger than that, okay? So that's not true, that's false. And then AB less than AC, it's an important principle. Okay. I multiply A by B, or I multiply A by C. Multiplying A by two different numbers, and this number is bigger than this number, which makes this product bigger than this product. Okay. So you want to kind of understand that that's always going to be so if A is less than B less than C. Okay. So big deal. If A, B, and C are in this order, that's always going to be so. So you kind of get a general principle out of specific numbers. Okay. Okay, how many numbers can you get by adding two of the ABC numbers? Well, there are only three possible pairs, A and B, A and C, B and C, right? So I could add these two, I could add these two, or I could add these two. Okay, well, what are the numbers? In my case, I wrote it kind of small, but you already know. A plus B is 12, A plus C is 14, B plus C is 16. Now, you might not have added them in the same order I did. You might have done B plus C before you did A plus C. You're going to be able to tell which one's bigger than which. And it's going to come out D, E, and F are these numbers in order. Now, I happen to have calculated them in order. I get 12, 14, and 16. Okay. If I calculate them out of this order, and I had to put them in order, so that D is always going to be less than E, it's always going to be less than F. Because again, the E and F are in order. And I have more room, I'd say, in order from least to greatest. Okay. So now, if you just know A, B, and C, you don't have to remember what D, E, and F are. You just put the A, B, and C numbers together to get the smallest possible number, then the next smallest, and the next smallest, okay? And then there's another way to put A, B, and C together, which is to add all three of them. And that's going to be bigger than any of these. And that's going to be 21. I get G equals 21. And well, you can do the same with your numbers. It's easier to understand how the numbers are obtained than it is to memorize the numbers. Okay. For most people, you got a really good memory, okay, memorize. Make sure you know how to calculate them. Fair enough, because you're going to use numbers throughout the semester. We don't want to have to remind people what the numbers are, so make sure you have your three numbers. You got to memorize those. And then either memorize the rest of them or remember how to calculate them, because it's really easy. Okay? Make sense? We're going to use those here in a little bit. Okay. Now, What's 5 times 2 plus 3? Well, 2 and 3 is 5, 5 times 5 is 25, right? So that's easy. What's 2 cubed times 3 squared? Well, 2 cubed is 2 times 2 times 2. That's 8, right? 3 squared is 9, 8 times 9 is 72. So I can kind of write these down. That's going to be 8 times 9 is 72. And I'm not even going to write that one down if we get that right. If I find that you made a serious mistake in some of these, I'll email you about it. Okay? Just give you some clear statements. Straighten out. Okay. 5 plus 9 over 3. Well, you add the 5 and the 9, you get 14 over 3. And some of them went on to say that's 4 2/3, which is good. Okay. The 14 over 3 is good enough. 4 2/3, along with 14 over 3 is even better. All right. Now, what's x plus y times z? Well, let's write that one out. I'll give myself a little more room here. X plus y times z is x times z plus y times z. Well, we could test that. EG means ergo, therefore, there's a 2 plus 3 times 4 is 2 times 4 plus 3 times 4. Well, 2 plus 3 is 5. That says that 5 times 4 equals 8 plus 12. 20 equals 20. That verifies it for these numbers. Right? And some people are going to want to say, well, that's x plus y times z. Forgetting to multiply x times z, right? And we understand that's not going to work. If you don't multiply x by z, you're going to get the wrong number. Means that this number multiplies both of these, and then we have them. That's a distributive law, and people often need a reminder about that. Not so much in this example as in one that's going to come up in a minute. Okay. Now, what's x to the 4th times x to the 5th? Well, I wrote this out. What's x to the 4th mean? Means x times x times x times x. What's x to the 5th mean? Means x times x times x times x times x. Now, how many x's have you got multiplied by each other? 4 of them here, 5 of them here, they're all multiplied, they're 9, right? So that would be x to the 9th. Now, I wrote that out last time. First of all, x to the 4th times x to the 5th. Some people are going to want to say x to the 20th. I bet I saw that. Okay. I know I saw it in the support class. At least a couple of times. Because it's confusing. Okay. When I was learning this, I had a little trouble keeping it straight. Okay. But I always knew to check it, so I very seldom made a mistake. So x to the 4th times x to the 5th is what? Well, use some simple numbers. 2 to the 4th times 2 to the 5th. 2 to the 4th, 16. 2 times 2, 2 times 2. Multiply by another 2, you're going to get 32. 16 times 32 is 512. Okay. What's 2 to the 20th? Well, you multiply it out if you want. 2 to the 10th is 1,024. 2 to the 20th is 1,024 times 1,024, which is over a million. Pretty close to a million, 1,048,000, 49,000. Okay. That's ridiculously different. Okay. So if you think you multiply these exponents, you're probably making a really big mistake, and you want to know how to check that. Because these laws of exponents are confusing because, well, you see, if you confuse this law with this one, or use the wrong thing here, it's really easy to do. You see multiplication, you want to multiply, don't you? Unless you think about what you've got. Series of 4x's times a series of 5x's is x to the 20th, and that's how I've written it here. This is what it means. You got 4x's here, you got 5x's here, that's 9 of them. Okay? And we really don't want to be stumbling when we're trying to learn pre-calculus over these rules. Doesn't mean you're not going to stumble every now and then, but every time you stumble, it sets you back a little bit, takes you a little longer to get things right. So get them straightened out. Okay? There'll be an assignment on it. I'm going over it quick right now. You might not remember everything I'm saying. You might not want to take the time to look at the video because I'm raving a lot. Whatever you do, though, get these rules straight early in the course so they don't trip you up later. Okay? Z cubed raised to the 4th. What's that mean? Now I could say, well, 3 to the 4th, let's say that's 81, so that's 3 to the 81st power. Okay, looks like you ought to do 3 to the 4th. You know, you go by what it looks like. It's easy to do the wrong thing. We call that doing math by superstition rather than by the rules. Okay, don't let superstition control what you do. It might kind of guide what you do, but always check it out. Okay, Z cubed to the 4th means Z cubed 4 times. Z cubed means Z times Z times Z. Z cubed to the 4th is this times this times this times this. Now how many Z's you got? You got 12, not 81. If you think it's 81, just try to do 2 to the 81st power. Okay, it's more than the number of particles in our galaxy. Okay, big number. Okay. Now, those are 2 places where people really strongly tend to trip up. Okay, so kind of be alert to it. This is another one. You think x plus y squared is x squared plus y squared. It kind of looks like a distributive law. I mean, we had a distributive law over here. If x plus y times z equals, we actually have the distributive law. Well, never mind. I don't think I actually wrote one out. It looks like the 2 ought to distribute over the addition. The square ought to distribute over addition, but there's no distributive law of exponent over addition. There's a distributive law of multiplication over addition. If I multiply x plus y by 2, I get 2x plus 2y. If I do x plus y to the 2nd power, I don't get x to the 2nd plus y to the 2nd. I'll prove it to you in a minute. Let's prove that this is wrong. We prove this is wrong by testing it. We'll put some numbers in. And these are easy numbers, 2 and 3. You don't usually want to use 1 as an example number because 1 has its own properties. The 2 plus 3 squared, is that equal? Question mark to 2 squared plus 3 squared. Well, you can work out the numbers. Clearly it doesn't. 2 squared is 4, 3 squared is 9. That adds up to 13. But 2 plus 3 adds up to 5, and you square 5, you get 25, and your answer is nope. Okay. This is a false statement. It's not always false. If you have 0 plus 3 squared, well, that's 0 squared plus 3 squared. You're going to get 9 either way. Okay. So if one of these numbers is 0, it's true. So it's not always false, but it's not always true. It's usually not. Almost any pair of numbers you put in here, this is not going to work out. Now, there are geometric pictures we could do with this, but I think they're more important geometric things for us to do due to the time we have left. X plus y squared is what? It means x plus y multiplied by x plus y, right? What's x plus y multiplied by x plus y? Well, distributive law, which is some people tend to be a little funny. Look at the camera zoomed all the way back, and you're seeing me instead of the board, and the board's really tiny. And I'm really big. That's a bad combination. Okay. not only did it zoom back, it reset itself, so I got it zoom and it's ridiculous. It's a great camera, except for that little flaw. And the little flaw that everything's blurry, but there it is. Okay. Where was I? Hopefully you got to see all this. It's small, you can probably still read it. It's a good camera. X plus Y quantity squared, X plus Y times X plus Y, meaning by the distributive law, which people is a little fuzzy on, is X times X plus Y times X plus Y. Because X plus Y times whatever is X plus times whatever plus Y times whatever. If whatever is the X plus Y, well, then we can do this. X times X plus Y means X plus X times Y. X times X is X squared, that's the X plus Y. X times X is X squared, and X times Y is X Y. And Y times X is YX, and Y times Y is Y squared. Not X squared. Okay. And XY is the same as YX, so we got two XYs here, so we got two XY along with our X squared and Y squared. So you see that we got this two XY in them. I can draw you a picture and make sense of that, some squares and stuff, but I'm not going to take the time. Fair enough? Okay. Other things. Okay. Z cubed to the fourth. Well, say I did it wrong. Just showing it's easy to do. Pretending to make a mistake. Okay. Wasn't really pretending, I just being done. Okay. So Z cubed to the fourth, you could write a Z to the 3 times 4. Multiply exponents for the reason you see here. You multiply how many Z's there are here by how many of those you need. 3 of these times 4 of them gives you 12. Similarly here, the rule is you add the exponents. That's a rule that's easy to understand. X squared plus Y squared is X squared. Put that down kind of sloppy. X squared plus 2x plus Y squared. Okay. Now 2/3 plus 5/3. You got the same denominator, that's 8/3. You can't do it with this one. You can't add the numerators and add the denominators. I didn't add the denominators here, did I? There's no adding denominators. Ever. Okay. But here, I have to have the same denominator. Okay. So you use a common denominator. 2/3 turns out these common multiple 3 and 8 is 24. So well, let's write this one out. Let's see if I've got room. Yeah. Okay, so let's do this. 2/3. If I have the same denominator, I can add them. Well, I can get the same denominator. Same denominator is going to be 24. And the way I do that is I take 2/3 and multiply by 8/8. Which is going to give me a denominator of 24. And doesn't change the value. 2/3 is the same as 2/3 times 8/8, because 8/8 is 1. 2/3 times 1 is 2/3. I haven't changed the value of this fraction. I've just changed the way it's going to look. And then it's going to be 5/8, multiply that by 3/3. So that is 16/24 plus 15/24, which is 31/24. Okay. And you could write that as 1 7/24. So you're going to have an assignment probably this week on fractions and exponents, which is an algebra 1 set of skills that you once had. And you just got to refresh. Fractions is a fifth grade set of skills. That's even easier. Not insulting you because people don't know how to do fractions usually. Because people put a calculator in their hand as soon as they start to understand fractions and never have to do them again. Curriculum is really terrible like that. Okay, and it's curriculum's fault, not yours. We'll still blame you. It's the curriculum, not you. Okay, now if you don't get it right in the next week or so, then it's on you. Okay, can't blame it on the curriculum because you can't pick up a fifth grade skill in a week. It just means you aren't trying. Okay. I've seen enough of your work already. You know you're plenty smart to do that. Okay. Another reason for this. Here's a number line. Here's 0, here's 1. Now, where is 2/3? Well, 2/3 is more than half. I mean, you divide this interval into 3 pieces, and right here is 2/3. I can represent 2/3 by an arrow. That's how big 2/3 is, right? And what about 5/8? Well, I'd have to divide this interval into 8 parts. Let's see. I divide it in half, divide each of those in half, divide each of those in half. 1, 2, 3, 4, 5. That's 5/8. Is that how you think about fractions? Should be. Okay, then you really understand. And instead of just following rules and give you the same answer as your calculator, this is what they mean. Now, in terms of what they mean, if I add this to this, is it going to be bigger than 1 or less than 1? Now, talk about it for a second. Okay. So yeah, got a quick answer. That was an excellent answer. Perfectly phrased. Well, 2/3 is bigger than half, 5/8 is bigger than half, so my add-on's got to be bigger than half and a half, which is 1, right? So this is greater than half of this is greater than half of this. So if I add the two, there's 2/3. And here's 5/8. Which is a little less than 2/3. I'm not trying to really drew it that way, but it's a small difference. Okay. And when I do that, each of these greater than half got to be greater than 1. So here is 2/3 plus 5/8. Now, what this demonstrates is why it's really a bad idea to say that we add the numerators and add the denominators. Okay. Why is it a bad idea? Well, if I add the numerators, I get 7/11. Is that bigger than 1? This has got to be bigger than 1, but if I add the numerators and add the denominators, I get something that's less than 1. It's absurd. And you call this in mathematics, it's a formal, reduction to absurdity. I've reduced the idea that you add numerators and add denominators to a complete absurdity, if you understand. Okay. So a lot of bad habits, this being one that I see a lot, this being one I see all the time. Okay. And many others. I mean, and these are, it's kind of understandable how you can mix these up, which is why I say reduce it down to some simple numbers. Okay. You can never, if you're not sure whether you add or subtract or multiply or divide those exponents, you get out a simple number. You learn how to do this right in 5th grade. Okay. you can refresh those neurons. It might be a little bit fuzzy, but it's not going to be hard. Just make sure that you understand that there's a fallacy there, that there's something there that people tend to do. It causes them all kinds of things throughout this course. Okay. And it's not just with numbers, it's with symbolic fractions. Okay. That's really tough. All right. Now let's move on. Okay. What about x plus 6 over x? Here's a bad idea that I see from 95% historically of students that start a pre-calculus course. Terrible. Doesn't mean you're terrible if you do it, because most people do it, and I don't see that many terrible people come into pre-calculus. I don't know about it. No, seriously. You know, you're not a terrible person if you do that, because you've got a whole lot of company, and 95% of the population. It's not true that 95% of the population is terrible. Okay. Depends what population you hang out with, but it's very seldom 95%. Several reasons why. Okay, well. Just do what I've done a couple of times, put some numbers in. Easy numbers, show it's not true. Okay. Now there might be some numbers that make it true. Okay. Just to give you about what might be common, we could write x plus 6 over x equals 6. Okay. That is true for one unique x. If x is equal to -5/6, we write a simple equation and solve that. But there are a couple of steps in there that probably going to be a little unfamiliar to you. We'll stress those as we learn to solve equations. Okay. But if x is -5/6, well, that doesn't look right. Oh, it's not -5/6. 5/6 then. Oh yeah, that's what it's 5/6. Okay. Okay, so what is x plus 6 over 6? Over x. Seems x has to divide both x and 6. Okay. You can't selectively divide one of these by x. It's a distributive law. I can say because, and this might seem a little mysterious to you. We'll work out the algebra. Okay. This means the same as 1 over x times x plus 6. And that means 1 over x times x plus 1 over x times 6. And 1 over x times x is x over x plus 6 over x. Of course, X over X equals 1, right? So we could write this in this form. This wouldn't really be a simplification. Okay. I gave you this, it simplifies to this. Well, that involves a little algebra. That everybody should theoretically be well equipped to do with just a little reminder, but it ain't so. So you're gonna have to spend a little time making sure you got the algebra. You're gonna have to spend a little more time in the course than you normally would in a pre-calculus course. If you aren't up on that much algebra. Okay, I don't expect most of the class to be able to do that algebra right now. Okay. But we'll see what we do, of course. Okay. So don't feel bad about it, just understand. That partly because of COVID, partly because the curriculum isn't that great, partly because you got too many people in an algebra class and it's not taught to the level it should be. And partly because you might have been a little sorry when you took it, I don't know. Some people are. Most people tend to try to get by with as little as possible. Sometimes for good reasons, sometimes for bad. Okay. Life can get complicated. So don't feel guilty about it if you didn't do everything you could now, because very few people do. And we're over time. Sorry, we're not going to be able to do what we're going to do. We'll miss rapid thought. Anyhow, the other thing is 6 to the 0 equals 1. Is any number to the 0 power is 1. 1 over 0 is undefined. Can't do it. Sorry to keep you over. And we'll proceed next time to see what we are going to do with the course. We're not going to start with heavy algebra.